So this is the rest of the trigonometry for the term, which includes angles of elevation, angles of depression, and working in the Cartesian plane. First things first, we have to remember SOHCAHTOA, our star acronym, where sine theta is the opposite side over the hypotenuse, cosine theta is the adjacent side over the hypotenuse, and tangent of theta is the opposite side over the adjacent side. Let's get into it. Okay, so the angles of elevation and depression are as follows. Angles of elevation, we have triangle FUN, where theta is the angle of elevation of F from N. So from point N, angle theta is the amount of degrees that F was elevated by. So point F is higher than where this line is, right? And so the angle of elevation between this line and the positioning of F is this angle theta. Okay, beta on the other hand is the angle of depression of N, this guy, from F. So if we consider this dotted line here, angle N is a certain number of degrees sort of downwards from where F is. So beta degrees downward is how N was formed from F. Now, important to note that point F and the point that is not named, let's call it point E, EF is parallel to NU, which I think is visible because they are both straight lines making a 90-degree angle with FU, right? And so, as I said, EF is parallel to NU, and for that reason, we have alternate angles. So angle N is equal to beta since we have the alternate angles equal. So, example 12 reads that the angle of depression of a boat on the ocean from the top of a cliff, which is up there, is 55 degrees. So we have that angle of depression there between the boat and the top of the cliff. Okay, then they say that the boat is 70 meters from the foot of the cliff. 70 meters from the foot of the cliff, and so the distance between the boat and the foot of the cliff is 70 meters. The first question is, what is the angle of elevation of the top of the cliff from the boat? So what is the elevated angle between the cliff and the boat, which is over there? Then the next question is, what is the height h of this cliff? Our first move should be to fill in as much information as possible. I would start by indicating my start and end point. So let's call this AB and CD, and it's clear that AB and CD are parallel. That being said, because of that, we observe these alternate angles, and so angle C is also equal to 55 degrees. If we look a bit further, we can see that these are two straight lines, and so therefore this would be a 90-degree angle forming between these two straight lines. And to find the height of the cliff, our unknown side over here, because it is a length, we can either find that using Pythagoras or using our trigonometric ratios, sine, cosine, or tangent. So let's see. Alright, first question, what is the angle of elevation of the top of the cliff from the boat? So between the boat and the top of the cliff, the angle of elevation, that upward measuring angle, is 55 degrees, We know that, but we got to that using the alternate angles. Okay, so this angle B, ABC, is equal to angle C, and so we write it as follows. We say that angle C is equal to 55 degrees, and the reason is our alternate angles, and AB being parallel to CD. So that is our first answer done. Answer for A. Then for B, they are asking us calculate the height of the cliff, and I said to you, you have two options, Pythagoras or the trigonometric ratios. Pythagoras would only work if you have two known sides and an unknown side, but we don't have two known sides, and so Pythagoras is not the one. Our next option is to use the trigonometric ratios, sine, cosine, and tangent. So let's start off by writing our little acronym, SOHCAHTOA, because we need to know which one is the appropriate option to answer our question. And so the three questions we ask ourselves is, what do you have? You have two things. You have the angle and you have the adjacent side. Okay, the second question is, what do you want? What do you or what do we want? Well, the question is telling us what we want. We want the height. So we want, in trigonometric words, we want the opposite side. Okay, and the final question, using what you have and what you want, we want to know, what can you use? Is it sine? Is it cosine? Is it tangent? Let's see. We need to have a ratio that includes adjacent and opposite, and tangent is the only one that can accommodate our needs. And so we write our equation as follows by saying that the tangent of theta, in this case will be 55, is opposite over the adjacent side, but our theta is a 55-degree angle, and so I replace theta with 55 degrees. So tan of 55 is equal to the opposite side, the height, over the adjacent side, the 70. Now that we have this equation, we can figure it out easily if we just draw a little triangle and we say that tan 55 is h over 70, and so therefore h is equal to 70 multiplied by the tangent of 55 degrees. Take a second to figure out or calculate the length of the height. Pause to work it out. Okay, your calculator should give you 99.9703, and rounded off to two decimal places, this would be 99.97 meters. Okay, because they give us meters in the question, and that is the answer to these two questions from this example.